Welcome. So now we're going to use what we've learned about the centroid to solve some problems. And you're going to see these go pretty fast once you know the relationship. So P is the centroid of triangle QRS shown below. And PT, oops, T got left off, equals 5, find RT. Obviously T has to go here, otherwise I wouldn't have a PT and a RT and a RP. All right, so PT here is 5, right, and we want to find, here's RP, and then we want to find the whole thing, which is RT. I'm just going to underline, kind of outline there so we know what we're looking for. And then the 5 there refers to just PT. All right, so now let's, always when you're solving these, write the relationship. Just going to write the relationship between your segments. Now there is often more than one way to solve. Right? And when possible, I will try to show you all the ways. One is not more right than the other. It's just a different way. Write relationship when solving median problems. All right, so let's solve for RT first. All right, so I'm solving for RT. RT is a green one. All right, so I'm going to write, it's outlined in green on, excuse me, no, it's outlined in red on mine. So I will use a red pen so that you can kind of color code it and match it. All right, so remember RPT is 1/3 of RT. Right, because from midpoint, this is the midpoint, this is the centroid. Right, so this is 1/3 the length, and this is 2/3. Right, so RT is PT is 1/3 of RT. So if PT is 1/3 of RT, how many PTs does it take to solve for RT? Well, if it's 1/3, it would take 3 PTs, right? So if PT is 1/3 of RT, if I have 3 PTs, I'm going to be equal to 1 RT. Now, which way is the better way to solve? We got 2 equations here that we could use. Really, it doesn't really make a difference. One might be easier though, right? So you get to choose. I'll solve them both ways, and then we can decide, did one seem a little easier than the other? All right, and I think I need to move this over just a little bit. Oops, it lost its 3. All right, so this is method number 1 and method number 2. All right, so PT is 1/3 of RT. PT, we know that was 5. 5 is 1/3 of RT. I want to solve for RT. I got this 1/3 here. How do I get rid of 1/3? Right? If we have a coefficient, we can multiply by the reciprocal. The reciprocal of 1/3 is going to be 3. And we know, and hopefully you know, that if we take 1/3 times 3, right? If you don't see that, you can reduce. You can just multiply across. And so 1 times 3 is 3, and 3 times 1 is 3. Why, that's 1. Or you could have said, hey, look at that, and cancel out the 3's. And that's just now 1. All right? Either way, it's 1. All right, so that means that RT here is equal to 15. That's one way I can solve it. I can also solve 3 PT is equal to 1 RT. All right, so PT was 5. 3 times 5 is RT. That means 15 is RT. Notice we got the same answer. Did it matter which one we solved with? No. I kind of think the second one was easier, right? But did it matter? No, not really. So I tend to so this is how I do it, and then if you like it, you can do it the same way. I isolate the one I'm looking for. Right? So if possible, I choose the equation that isolates the segment I'm looking for. If you like that idea, then go ahead and use it. The nice thing about it is it tends to make for a little less work. But if you want to write it the same way each time, there's nothing wrong with that. All right? So here, I think I had a little less work. And notice that we're solving for RT. RT is isolated. Right? We're not quite done. We need to solve for RP. We also have two ways to solve for RP. I'll show you both of them. You pick the one you like. All right? Sometimes you don't have a choice. Sometimes you do. Here you'll have a choice. All right? So if I now know what RT is, right? RT is 15. I can certainly use that. There's nothing wrong with using the big segments you solve for. All right? I know that whole distance there is 15. So now I know that RP is 2/3 of RT. Right? And so I'm looking for RP. We isolated it in this particular one. All right? So you can always write it as, you know, the midpoint to centroid is 1/3. Vertex to centroid is 2/3, and write it that way all the time. Or you can just multiply by the reciprocal and figure out how many PTs. Takes 3. Would take 3 of midpoint to centroid, and it would take a little tougher to figure out the 2/3, huh? Right? So a little tougher to figure that out. By the way, it would take 1.5. But you might find out that hard to remember that, so I wouldn't worry about that. So that's actually not going to be my second method. I tend to set it up on this particular problem one of two ways. If I didn't know what PT was, I'd solve it this way. If I don't know PT, I'd solve it this way, the method I'm solving. So that's method number one. So RP is, maybe I didn't know what PT was. I just knew what RT was. So RP is 2/3 of RT, and I know that RT is 15. All right, if you have trouble multiplying fractions, just remember every integer value has a denominator of 1. All right, so now I could reduce. That would be a really good idea. All right. You can cross-reduce when you're multiplying. All right, so 3 goes into 3 one time, 3 divides into 15 5 times, and 5 times 2 is going to give me 10. Squeeze it in there. What if you didn't reduce? Would you get the same answer? If you just multiplied and reduced later? Sure, yes you would. All right, so if I don't reduce, just for those of you that maybe have trouble, I have 2/3 times 15. And I just multiply. I get 30 divided by 3. And what's 30 divided by 3? Of course, that's 10, right? But let's go back to our problem. So RP is 10. I'm going to erase this stuff because this is just kind of a review of fractions, and that's really not what I was trying to teach you. I was trying to teach you solving for the median. This is my second method, and this is if I know PT. All right, so if I know PT is, I know what RT is. Notice that together, RP plus PT equals that whole segment RT. The one I don't know is RP. I was given PT is 5. We found RT, and that's 15. If I subtract 5 from both sides, RP is 10. All right? So I tend to use method number 2 if I know the other segment. I just subtract. All right? You can use whichever one you like. All right? You may switch back and forth. You may not think about, you may not think about subtracting. You may not, cross your mind, and then you solve for it as an equation. That's okay. All right, so I'm going to, as we go through these, I'm going to solve different ways, but I will tend to choose the way that's easiest and not solve every single problem, every possible way there could be to solve. All right? But if you see a different one, you want to ask me about it, that's fine. All right? I don't want to make this a 3-hour video by solving every problem every different way. Oh, and I happen to have that up there, but I don't need it. We already solved for that. All right, so in triangle LMN, RL is 21, SQ is 4, and QM is 7. And if QM is 7 is not in your notes, add QM is 7. Okay? All right, so we want to solve for all of our missing pieces here. And these are already written as equations. Right? So we're just going to be following along and doing these equations exactly the way it's written. So LS is right here. We're going vertex to centroid, right? That's going to be 2/3, right, of RL. Right, so LS is 2/3 of RL. Do we know LS? No, we do not. That's the one we're solving for. Right? We know RL. Actually, if it helps, we could write it on there. So RL is the whole length there. I don't know what color to write it in. I guess I'll write it in blue. So this whole length there, it was given to us as 21. SQ is, I'll switch colors, is this length here. Right? That one there is given to us as 4. And QM here is given to us as 7. Okay? All right, so we already know what RL is. So LS is, just continue writing 2/3 of 21. I'll solve it down here just so that I not require you to write it out if you can multiply, if you can figure out 2/3 of 21. We're multiplying, by the way. Because if it's 2/3 of, it's multiplication. All right, we could reduce this, and that's a good idea. I'm doing this just in case you have trouble multiplying fractions so that you can get better at multiplying fractions. Right? I don't really require you to have on the side there how you multiplied the fractions. I'm fine if you have 2/3 times 21 and you multiply and you get 14. Right? And you should be able to hopefully do that in your head. If you can't, then maybe writing it out is a good thing until you can. All right, so let's solve the next one. And I'll do it in green because that matches what I wrote SQ in. SQ is blank of NQ. Right? So NQ is this whole length here. And of course we know that SQ is 1/3 of NQ. Right? It's from centroid to midpoint. So SQ is 1/3 of NQ. This time we know SQ and we don't know NQ. I would have, if I didn't have an equation already written up here that it's fill in the blank, I would actually have written the 3SQ equals NQ. Because I like to have what I'm looking for isolated. Right? But this equation works perfectly well. Right? And you use whatever you prefer. All right, so 4 is equal to 1/3 of NQ. Right? I have to isolate NQ. Right? So we're going to have to multiply both sides by 3. Right? So that means that NQ is equal to, because 3 times 1/3 would cancel, it gives me just NQ. That means NQ is equal to 12. Right? And it's not a bad idea to think backwards. Right? So here, right? So if NQ is 12, SQ is supposed to be 1/3 of 12. 1/3 times 12, that's 4. And yes, that checks out. So not a bad idea on a formative or benchmark. And then the last one that we're looking at here is QM. QM is equal to how much of LM? Remember, Q here is a midpoint, and it divides LM into 2 congruent segments. I was going to say pieces, but kind of like the word segments better. And it even has it up there on the problem. All right, so that means QM is half of LM. So 7 is half of LM. I'd have to multiply both sides by 2. Right? 1/2 and, here it goes like that. 1/2 and 2 just equal 1, right? That just equals LM. And 2 times 7 is 14, and you can always check your work, right? So QM should be 1/2 of 14, and 1/2 of 14 is 7, and QM is 7. Right? So that one checks out. Another problem done. Good for us. Right? There's not too many more of these. Right? This might be the last page. Let's finish this one up. All right, and I'm going to solve it the way that I think is the easiest. It doesn't mean that you couldn't have solved it a different way. Right? I'm just going to choose the one I think is easiest. And that is I'm going to isolate what I'm looking for. So if GF is equal to 15, then KG equals, and I'm going to write each time and erase it because the numbers keep changing. Right? They're not, I don't know if they're necessarily all the numbers or they're just, using different numbers each time. All right, so GF is equal to 15. We want KG. Now here's one we haven't done. how much is that part? So we have to think, what's the relationship between GF and KG? I'm going to write that down. So what is the relationship between KG and GF? Well, let's think about 1/3 and 2/3. Right? So KG is 2/3 of FM. Excuse me, KF. KF, the whole thing, KF. Right? And GF is 1/3 of KF. Actually, I'm going to move this over here. I think you have this one in your notes, so hopefully you have it written, because I don't have any room to solve, and so I'm going to move this over here. Oops, but not that. There we go. I just want to move that. So, in other words, 1/3 times, oops, I almost gave it away. I probably did. 1/3 times what equals 2/3. Hopefully you said 1/3 times 2 equals 2/3. And that means that it takes 2 GFs. I'll write it down here. It takes 2 GFs to equal 1 kg. Or GF, oops, is equal to half of kg. I'm solving for kg. I like this one here where it's isolated. Nothing wrong with the other equation though. It's just the one I like better. So if it takes 2 GFs to equal kg, it's going to take 2 times 15 to equal kg, and that's 30. And even if the math seems really simple, it's like, oh, what do I have to write it down? I'm multiplying 2 times 15. What I want to know is, do you know the relationship? Because that's the big thing. Right? So always write the relationship between the segments before solving. Oops. So I have a box here that's a recording box, and I can't write where it is, but you can't see it between the segments. But I can't write unless I move that box. All right, so now let's continue on. We'll do the rest of them. All right, that was the only one we haven't talked about. All right, so JG is 13, so that's right here. Then JE is, so we want the whole segment there, right? So JG, that is the from vertex to centroid. Right, so I want the one that's, I want to use the one that's, normally I like to use the one that's, I want to isolate the one I'm solving for. There it goes. Sometimes I don't, right? And this is one of them, because I think it will find it easier just to write the same thing each time, and that is JG is equal to 2/3 of JE. So vertex to centroid, right? JG, the vertex to centroid, is 2/3 the median. On this one, you're not going to want to write it the other way. It's easy to figure out 1/3 and 3. If it's 1/3, it takes 3 of them. If it's 1/2, it takes 2 of them. It's not as easy if it's 2/3. How many does it take? You certainly can. It's 3/2, but you don't have to. So I'm not going to bother to do it that way. All right, and it won't be that much of a difference. So JG is equal to 2/3 of JE. Always write the relationship. Then I plug in. The one I know is JG. So 13 is 2/3 of JE. How do I solve for JE? We multiply both sides by the reciprocal, which is why JG is 3/2 of JE. Or excuse me, it takes 3.5. Or excuse me, not 3.5. 3/2. 1.5. There we go. 1.5 of JG to equal JE. I'm good with the math. Sometimes my tongue wants to get tied. All right, so this is 39/2. All right, that doesn't reduce. So we have 39/2 equals JE. you can write that as 39 halves. Right? Or you could just write it as, right, it's terminating decimal. Right? So if it was 40, it would be 20. This is 19.5. Right? And then it's the last one, which I think is the easy one on this particular page. All right, so JL here is 22. What's FL? Right? And so we're looking for this one here. And we know that FL is 1/2 JL. Or I could say it takes 2 FLs to equal 1 JL, but I like to isolate the one I'm solving for. So FL is equal to 1/2 of 22, and that means that FL is 11. Okay? And then the last three here, if KE equals 20, I'm just going to keep erasing this each time, give myself space. KE equals 20, so KE is right here. We want to know KL. Actually, both of these are about, this one and the last one were just as easy. All right, so we're solving for KL. Right? KL is twice the size of KE. It would take 2 KEs to equal 1 KL. I know what KE is, so KL is 2 times 20, and that means KL is 40. We want to solve for the last one, and that is, right, purple this time. All right, so DL is 24. And we want to know LG, right? And we want to know DG. I tell you, I think solving for DG is easier. All right, so let's solve for DG first. All right, so DG is equal to 1/3 of DL, right? So DG is 1/3 of DL because it's from midpoint to centroid. So DG is 1/3 of DL. DL is 24, so GG is 1/3 of 24, and 1/3 of 24, why, that's just 8. Now, the easiest way to solve for LG, right, is, well, one of two ways. You can either do that LG is 2 times DG, or you could do that DG plus LG equals DL. And actually, I'll write it that way. DG plus LG equals DL, equals the whole thing. You could also, but, whoops, there goes my color purple. You could also, by the way, although I'm not going to solve it out, you can put this in your notes. You could also use that LG here is 2/3 of DL. Any of these would work. I think the bottom two, LG equals 2 GGs, or DG plus LG equals DL, works really well. So LG would be 2 times 8, which is 16. Oops. All right, so LG is 16. I'm going to move this one out of the way. And I may actually use that one as well. And, or I could do this one. I know DG. DG was 8. We don't know LG, but we know DL. DL is 24. If I subtract 8 from both sides, LG, my G is looking like a 6. And my L's look like an angle. Does that not look like angle G? All right, so 8 plus LG equals, oh, I wrote that down. LG equals 16. We just have to subtract from both sides. All right, so it's fine. It's red. We subtract 8 from both sides. I can get this. I tell you, it's hard to hold the microphone with your arm. So DG plus LG equals DL. One last try. We know DG, it's 8. DL is 24. And you subtract 8 from both sides, it's 16. Yay! And you could do LG is 2/3 of DL if you wanted, just so you can see that also works. LG is 2/3 of 24, right? So you could reduce that. 3 divides into 3 one time, 3 divides into 24 8 times, and 8 times 2 is 16. And that's enough ways for anybody to solve for LG, which is 16. However you want to write it, solve for it. All right? Thanks for watching, and bye for now.